Hello there, welcome to Codebase Alpha. It feels like forever since the stream was last on, but it's been it's been incredibly busy at work. So lots of stress, lots of late nights, lots of problems. So I haven't really been able to stream up until now. So we're still not out of the woods with the work issues, but hopefully we can kind of get back on track. So this is a bit of a later stream than normally happens on a Wednesday, just to try and catch up, especially with the shader. Stuff that we're working on with Mårten. So Mårten's here in the stream as well. So let's hop straight over to our pair programming area, and let's do some code.
Yeah, hello there.
Hi Mårten. So welcome back to the stream. It's really good to see you, and we've got on the screen at the moment what we did last time, which is our kind of morphing blobs, which are passing through each other. And I really kind of enjoyed this one. So this is all up on Shader Toy now, and I think I've got it going with actually 12 of these blobs merging with each other, and it's quite fun to look at. So
yeah, and it's I mean, it looks kind of hard, but as we talked about last time, it's not that hard
to
get to work. And what looks really hard is this, that they actually are merging into each other. But that's the simplest thing of everything in this whole program.
Dragon, welcome to the stream. Good to see you.
So I've actually been coding TypeScript this week.
You've been doing TypeScript?
Yes.
Wow. And how are you finding TypeScript?
It's all right. I've been spamming some channels, asking some questions, because it's going to be my first week with TypeScript. I kind of been a little bit exposed to it, but I'm really kind of new to it. So
yeah,
and also React as well. But I feel like I mentioned to you, I'm already in the dark corners of the language.
Yes, it's amazing how quickly you reach those. It seems to be a trait of yours.
I don't know if you read Lovecraft.
I do. Yes, I love Lovecraft.
I also love Lovecraft, and many of his heroes, whatever, they get involved into some bad stuff because they are like drawn to the evil of the world. Like, for instance, not all of them, but some of them characters are like that. And I feel like I'm like that with programming languages. I'm drawn to this. You shouldn't go there.
Yeah, don't go down the steps into the cellar, or don't go up to that belfry.
The alleys, the alleys, sort of the cramped alleys, dark. No, I'm heading down there. It must be good stuff down there, I think.
It'll all be fine, yeah.
And then I come out scarred, and I've seen things.
So how's that gone? Have you managed to get what you want out of TypeScript? Because I know it was because of some issues with Blazor that you went down that alley.
Yes, Blazor, yeah. So I was really excited about Blazor server side. So no, but what I want to build is for work, for an example, not for work, but for work, to demo to people at work about a concept which is called formlets, which I talked to you about sometime.
Yes, we must do something on formlets when you got it worked out to what you want to do with it.
Yeah, and it's basically it's parser combinator, but instead of building parsers, we build forms in the same way. Seems, when I first saw it, it was mind-blowing to me. Like, how can you do that? It seems impossible. But it's actually, I think, extremely powerful way to build forms. So, but because I'm usually using dead languages like F#, not really dead, but very obscure ones for many people. People tend to be very confused about F# syntax and cannot really see how that can be applied in their language. I thought, well, let's do it the other way around this time. I do something in TypeScript, and maybe I can get people to see at least that there is a point to this idea. So that's what I'm doing, and it's actually going quite well. I have an almost working example now.
Excellent.
Talk about Blazor server side. Yeah, I was disillusioned when I realized that Blazor server side actually has a pretty strong coupling to their thinking about how to build components.
Right.
And I'm sure many people will be able to sort of deliver a lot of very good stuff built on Blazor server side and building component-based UI. But what I want to build is this kind of very dynamic and emergent UI from a sort of functional composition. And there is no components there you can talk about. And that what happens then if Blaze is server side is that the way they do delta updates of the client side DOM from the server side DOM, it doesn't work at all with how I need it to work. Right. So I had to keep it up. But that's another story.
Yeah, we must have that on stream at some point when you say when you get into a form you'd like to kind of show the world and not just your work colleagues, and we'll get that. Something on that.
Yeah,
great.
But it's getting there. But let's talk. Shall we talk about shaders?
Let's talk shaders. Yeah. So we've got this wonderful shader here. So it's got a reflection on it. It's got the spotlight on it, and it's got shadowing. So what else can we do with it? Can we kind of get a bit more fancy with it?
You said reflection here, but I'm going to slightly correct you on that thing and say it's not really a reflection. It's a kind of fake reflection.
Yeah.
But one way to do it is that we do proper reflections, or we take it even one step further and we actually do refractions, which allows us to do transparent objects. Because I think that's kind of cool. And it was some time since I did transparent objects, but I think the basic framework we have here is okay.
Yep.
And let's see if we can add refractions. Now, the way refractions work, we're going to cheat here, right?
Oh, yeah.
That is, we need to cheat because we cannot do it the proper way, because even though the GPU is very fast, we're going to run out of GPU cycles. And then we don't get real time. So the way we do refractions is we are going to compute the intersection of a ray from an eye to the surface, just like we're doing now.
Yeah.
But when we hit that point, we compute the normal, and from that point, what we normally do is we always want to do is kind of properly. We compute a reflection angle, a reflection ray, and a refraction ray, and follow both of them.
Right.
But that doesn't work for us here. So what we're going to do is we're going to ignore the reflection ray and just do the refraction, and sort of to get the transparent look.
Okay, yeah, sounds good.
But I think that's going to look cool enough to sort of distract us from the fact that it's not really that's not really reflection. So there is actually a function built into now I need to open an example so I have it in front of my eyes, so I can sort of, because I cannot do everything from memory. It might shock you to hear that, SMB.
Mm-hmm.
But I actually need to sort of look sometimes to sort of remember how things worked. And another sort of interesting thing here that's also going to sort of make things a little bit more complex for us is Snell's law. Yeah, I kind of remember that.
Oh right, yeah.
There's something called Beer's law that we can use when it comes to refraction. Unfortunately, it's not beer.
It's a shame it's not real beer, isn't it?
Yeah, but still pretty cool stuff.
Yeah.
But so GLSL, which we're using here, doesn't support recursion. So that's so how we typically do reflection is that we hit the intersection point, and then we do a recursive step to find the next intersection point, and so on and so forth. But that is recursion is not supported by GLSL, so we have to implement recursion as a loop instead.
Okay.
But that's totally doable. But these are the kind of things that sort of make things a little bit harder for us. So maybe we should start by picking a simpler object than what we're having here, so we're not distracted by this thing here.
Yeah.
Because it's going to be hard enough to get this right without this distraction. But I would suggest to keep a sphere and keep the box below the sphere as well.
Okay,
so we remove all these extra spheres.
I think it's.
Let's save a new file. So
I've saved it into a new file. So we've got two spheres there. If I make that 0, there's a single sphere.
Yeah, so let's remove that loop altogether. So now what we're having here is, and this we can reuse. This part of the code is fine to have here as well. We should also stop the rotation, because that's also going to confuse us when we are looking at this thing here.
Right, so the rotation is the rot function here, and that is, where's that?
I think you're rotating the camera below. So if you go into where the camera is, that's at least I think how it's done.
Right, have a look. Render.
Over here. I think it's in the main method.
Is it? Okay.
So then you have a rotation here, right?
Yeah.
So
is it this one here? Is it?
And then you rotate it. So if you, yeah.
There we go.
So now it's a boring sphere with yeah. Maybe we can start with reflection and then get reflection right, because it's kind of the same thing, but
okay.
Reflection is a little bit easier, and then we can change it into refraction.
Okay, that sounds good.
Yeah. So what do we do? How do you do this thing? Well, go into where we're going to do the shaders. If you go into this function called render.
Yep.
And so what's going to happen here is we start here at something called array origin, and we have array direction. So what's going to happen here is we are going to find the intersection, and then we are going to and then we're going to start from that point where we intersected the object and reflected the array. So the array origin and the array direction are going to be updated.
Okay.
To point in a new direction. In addition, we're going to sort of accumulate the colors, because each time we hit a reflection, part of the object is going to leave a little bit of itself, and then we're going to, we're going to meld the sort of the object's natural look, kind of its color, with the reflected look.
Yeah. Okay. Sounds good.
So we're going to do that as well. One of the things we actually could do to sort of improve the look of this thing is improve the skybox. That is something we could do that is quite simple.
Yeah, it's a bit kind of boring and grey, isn't it?
It's kind of boring right now,
yeah,
don't you think?
I do.
And so many ways of doing that, but I have like a default skybox that I go to, which is well, let's try that one, and we can talk about how that is done, because that is a small topic, but it's also a little bit interesting.
Okay.
So I'm going to share some code here in this live code sharing site.
Oh yeah, so I need to log into that, don't I? Was it code share, wasn't it?
Yeah, and I think the old link we had before is going to work this time as well, because it seems that live. What was called live code share?
Codeshare.io.
Oh yeah. I actually don't think I've done an interview once in codeshare.io.
It's an interesting concept, yes.
I was interviewed.
You could certainly, I think I can certainly see interviewing people who want to work from home that way, because that would save them having to travel around. I'm in the which one are you in?
I'm trying to sort of figure out. Yeah, well, that didn't work. Okay, sorry. Give me a little bit second. So I'm gonna share the code with you in the chat.
Okay.
And then you just append the code to the live share thing, right?
Yeah. I think that's the one I'm in.
I think so. I'm going to try to share some code now.
Yeah,
so let's see how it works. Did you see something?
No. Let me just try refreshing.
It says sign up to save code. Maybe because this is old.
Right. Okay.
I'll make a new one.
Yeah. Sorry about this, folks. It's just we need to get this sorted out. We did plan on starting at 7:30, but as both Mårten and I were ready, so.
And the good thing in YouTube, we can cut all this away and sort of, so we can have the pretense that we actually know what we're doing.
Yes, which is always the trick when you're streaming. Okay, there we go. Got you.
Okay, and now I'm going to try to share on a different computer, because on my other computer is actually where I'm having. What if you type something? So see if I can see it.
You see that?
Yeah, that seemed to work. Let's see if I can write something here. Or maybe it's because I'm trying to sort of, oh boy. Yeah, maybe it's not like multiplayer, like you can have multiple.
Yeah, it is. It's weird, yeah.
Yeah, it just was a little bit delayed. So if you take that code and you put that into above render, it's missing a function called saturate. Let's see if I can find it. Saturate is a very simple function. Yeah, so if you add these.
Okay, get those in and put those up near the top, because they seem to be pretty fundamental functions.
So, did it compile?
It seems to be still there.
So let's try to use this Skybox, and it's very simple to use. So if you scroll down into render function,
yeah,
and scroll down, you see it says ray intersected sky.
Yeah.
So instead of returning sky color, you return get sky color. I forgot the name of the function immediately.
I'll find it. Get sky color.
And what you put in is the ray direction we're pointing on, because we are walking along a ray direction, and that means we're gonna. So now, if you put back the rotation that we removed, you can here, right?
Yeah. Oh, that's nice. Yeah.
Yeah. So you see, we have something that looks like a sun. We actually have two suns. But here's the problem: the reflection completely ignores that.
Yeah.
It's like, yeah, whatever. We have faked the lighting direction, so it's not lunar. But that's actually quite simple to fix if we want to do that. So we can start with a simple way to reflect the sky into the ball we're having here.
Yeah.
And so that's actually quite simple to do. And what you can do now is you go up into the render function. We can stop the rotation here if you pause. Keep that one, but pause the to the left.
Ah, there. Yeah.
It was easier.
Yeah.
So what you can do here is now you can actually compute the reflection. Let's say for an under float S here.
Yeah.
We can compute the sky reflection. Oh yeah. Okay. Yeah. So now we need the code in specular. So we made functions. They should never make functions.
Complete waste of time.
Yeah, complete waste of time. So if you go into specular.
This is a specular reflection, yeah.
Yeah, it does a reflection. We need that reflection. So if you copy paste that, you take reflect LD nor L, yeah. No, reflect LD nor. That's what we need, right? Yeah.
Oh, this is the built-in reflection function, isn't it?
Yes, it's not hard to do a reflection. It's just that it's better. This is so common, so they built it in. And then you say vec3 ref, whatever, I don't know what you want to call it. Ref dir. Equals semicolon.
Yeah.
And now what you do is now you sample you sample you do get sky color, but pointing in direction of the reflection.
Okay. That's going to be vec3 again.
Yeah, vec3, ref color, or I don't know what's called.
Maybe it's called get sky color. And that's ref here. Okay.
And then what you can do is in this return function, you just take ref color plus, inside this, when you multiply, you just take it plus, not there, but before or after multiplication. Inside the parentheses. Plus ref color.
Oh, yes, okay.
So that looks weird, but just multiply that by 0.3 or something like that. So now what you're actually seeing is, I think, start a rotation and we'll see what's happening here. If you press play again.
Oh yes, play, sorry. Interesting.
I kind of thought that it could be just, it seems like because let's see now if you can see. Yeah, it looks like it's something wrong. Let's reverse one of the in this ref D. Let's reverse the LD here or whatever. So just put the minus sign on it. Yeah, that looks better, I think, actually. Yeah, that looks better. So the reason I think this looks better is because above here, which you don't see, there is a big plane of white light. And that is what we see here now. Now we see the reflection of this on top of the sphere. Before it was kind of below. That seems strange.
Yeah.
Because I kind of knew that this was on top of everything. So I actually think that this is probably how it should look, my guess. Well, that's one way to do reflection. But now we are reflecting just the sky, right?
Yeah.
So the next step we want to do here is, but this is a little bit step forward in the right direction. We can pause this thing here. So I think we're going to remove the specular lighting because that has no real sense here, or it's just going to confuse us. So remove the specular lighting. The diffuse lighting is good, but the specular lighting can remove. And remove the computation as well. Yeah.
Yeah, makes sense. Yes.
We can get specular look from the reflection. But let's look at this get sky color. I just want to explain how it works because it's not very hard. So what we are having here is we're having light +1 and light +2. That is the position kind of in the sky of the suns, right?
Yeah.
And the light color is the sort of the colors of these suns. And then inside the get color, inside this in this get sky color function, what we do is that we have a ray direction and we compute the light direction, which is the position in the sky. And what we do then is that we are taking the dot product between the ray direction and the direction towards the light.
Yeah.
And the more the light kind of, the more they are parallel, this brighter we want it to be in the sky because we're looking more and more directly into the light by looking into that direction.
Yeah.
That's the kind of idea here. And can I see if I can type here?
Yeah, you go. Yeah, you're okay.
Yeah. So what we can do here is many people that when they build this kind of build functions this way that it's easy to comment out stuff. let's see if I can comment on stuff. If I just can find the correct characters. Now, where is the?
Shall I do it?
Where is the slash?
There you go.
And comment out the next line. And the next line. So this removed the skybox, the thing, this white we had on top. Now we just have the suns.
Okay, right, good, yeah.
Yeah. So how does the suns work? Well, I'm going to change that here. So this, by changing the power here,
okay, right, yeah.
Sort of focus that into sort of, or make it more diffuse. And that is because when you take the dot product, the more we're looking into the direction, the more intense it becomes, right?
That's right, because we're looking directly into the rays, yeah.
Yeah, and normally the dot product is like this, right? But it's too spread out.
Yeah.
It doesn't look all right, or in this for our sense. So what we do here is then we are taking here. But what we're seeing here is the outer corona, I don't know if it's the right word, the inner part of the sort of intense white lighting. This is actually this part here.
Okay, right.
So if you do this, it's very like this, and I can sort of focus that here. So it's actually very simple to sort of experiment with different kind of, how we want it to look, I think.
Yeah.
You just change the power and, yeah, this looks fine. I keep that. So I think it's very simple. I don't know if you agree, but I think it's quite simple mathematically, but it still produces an effect that looks kind of all right.
Yeah, it's really good.
Yeah. And we have different colors here, and we can sort of tweak them and make them, look better or worse, whatever. But I kind of like this skybox. I used it many times. I kind of think it's a simple and all right looking. But that's how this sky color works. Make sense?
Yes.
So as usual, not very hard when it comes to ray marching.
Yeah, it's always amazing how actually it boils down to some very simple mathematics, doesn't it?
Yeah.
And you say the whole kind of process of you get some code like this and you can just play with it, just tweak it.
And if you comment this thing out, line here, and the next line. Now we remove this sum.
Yeah.
It's no longer there, right? So it's very easy to make changes and sort of tweak around and add a third sum, whatever. and I don't know, but I think many that works with shaders have a general idea where they want to go, and then after that there is a lot of experimentation, and you end up with something that looks good, and then you keep it. But it's not always you have this. I don't think most are working in a very precise manner. Maybe the best ones are, but I think most of us that are doing shaders are like, we have a general idea, we look at some examples and we tweak it, and it looks good, and we kind of, we are genius because it looks good.
Yeah.
But really, we were thinking around, and that's also why I like shaders, because I like thinking around and get results. I've been programming like for 3 weeks on something at work, and it's still not working. And here we just changed a few lines, we got something cool.
Yeah, and it's all in real time. As you say, as we comment out the code, it actually reflects in the background there. I really like this idea. It's fantastic.
It's very good. They actually, so we are talking about, but they actually released a new version of IDE, and they asked us to pay for it. So this is actually I don't always buy software. I don't pirate software, but I don't buy either.
Yeah.
I buy games, but then I use the free versions often. But I actually bought Kodelife immediately because I felt I want to support these guys.
Yeah, they're doing a really great job.
So I just a drop of a hat. Yep, have my money. I think you're doing a great job.
Let's just give them a bit of a shout out in that they're over at Hexler, Hexler.net, I think it is. So let's go over there and. Hexler.net. So if you're interested in Kodelife and want to, you don't have to pay for it, but it's it's
you don't have to pay for it. The idea they have is you get a little nag screen. If you like the software, try consider buying it. But if you don't do it, right?
Yeah.
But for me, it was pretty obvious. I wanted to sort of buy it, and But what I really want from happening, and that was I sent an email to them, I want some cool examples how to use this editor in ways that I don't know.
Yeah.
Because I know some things, but I'm pretty sure I don't know everything. And I want some cool examples that I can say, oh, cool, I can do this as well.
I think the documentation side's probably when they need to work on, as you say.
Yeah, the documentation is not that good, really. It's saying, oh, you can press this button. Yep, did that. Yep. But how do I just want some examples. That's kind of what I need.
Yeah.
Anyway. So in order to make this work, what we're going to do a for loop here. And then I'm going to do some guessing. So we can start by making a for loop up here. And I would also make, before making a for loop, yeah, we have the color here. Can we scroll down?
Yeah,
Sorry.
yeah, you carry on.
Yeah, we have color there. That's good. Because what we're going to need to do now is we are going to need to sort of compute a color, and then we need to sort of have an aggregate color. So this is going to be we are going to aggregate colors. So this is going to start at 0. At least I thought so. This color is actually used for something. It's a color of okay.
Color of the sphere, isn't it? Yeah.
Yeah, that's fine. I forgot.
So, Rocket World, I don't think Martin would particularly want to answer your question on stream, but it's up to Mårten.
I work at the Chipset Media Group. So, or what's it called? Which is a kind of big company. So you can revert this thing.
What do you want to do? Sorry.
You revert my changes.
Okay. What did you change? You changed something to 0, did you?
Yeah. If you go undo that.
Yeah.
So make a new vec3, which we can call aggregate color or something like that. I don't know what you can call it, whatever you want. But we're going to aggregate a result there. This is going to be the final color that we're going to produce. But we are going to do multiple iterations on this thing here.
I'm going to use long words. So vec3, if anyone doesn't understand, that's
I can understand this thing. I don't like that.
This is a three-dimensional vector. So aggregate color equals. I should call it AC, shouldn't I? Really, to fall into the. But we'll call it the full name. Okay.
Okay. For the stream.
Yeah, for the stream. We'll take it for the stream.
So if you type vec3 here, 0. 0.
Okay. I'll put 0.0 just so it's shader toy friendly.
Yep. Yeah. And then you kind of learn to do that after a while. Yeah. Try to keep it reasonably friendly. And then you scroll down. And instead of returning color here, you assign the aggregated color the result. Hello there, Cody the Beard.
Hi, Cody Beard. Welcome to the stream. So where are we looking?
Instead of return, you make an assignment.
Okay, down here.
That, for instance. So instead of returning a color, we're going to.
Oh, here, right? Okay.
So we're going to assign this color, and you can actually type aggregated color. Plus equal, because when we're going to do the for loop, we're going to sort of it didn't find it. Might be a misspelling somewhere. This is why I call it AC.
Aggregate,
you see?
color. There we go. There we are.
And then you do the same thing for sky color.
Down here, yeah.
Yeah.
So the sky color is.
You take aggregate color plus equals sky color.
Okay.
And now it's all kind of weird looking. So what you do now is that you return aggregate color at the end. This is really advanced code, right?
It is, certainly is. This is way beyond me.
Yeah. TBD Gamer, hello.
Hi there. Welcome to the stream.
So now we have started our refactoring towards adding reflection. Now, because some people are new here, when we do reflection on this thing here, we're going to compute the reflected array, and usually what we do in normal programming language, not GLSL, we have to do recursion, but we don't have recursion in GLSL.
Yeah.
There is no recursion, so we have to do a for loop instead.
Okay.
So what you do now, for instance, is you can just say, well, let's make a for loop on top here that you sort of wrap everything with here.
So we want it up here, do we?
Yeah. I'm also I want to warn people that I'm actually going from memory here, so you can expect disaster.
We like disasters, though.
Yeah.
Okay.
And then you say int I or int something, a variable that you're going to iterate equals 0, and I less than 2. So you do 2 iterations. Ah!
Oops.
This is actually one of the bugs in
Crashed,
Kodelife.
yeah.
Oh yeah, I should have.
We should have saved.
You should have saved.
Yeah.
Well, what we did wasn't. We haven't done so much. We did the Skybox thing.
Yeah. So let's see if we can get.
Yeah. So for people that haven't experienced this bug, so what happened there was that we wrote an infinite loop, and then I guess the graphics card don't like that we're doing infinite loops per pixel. So something crashed, and Kodelife didn't really handle that properly. So that's actually, in general, I think Kodelife is quite stable. But when you start writing infinite loops, things can happen.
Okay, so there's that change we made.
Yeah.
Have we got the Skybox over here? Yeah, there's the Skybox. I think there was some constants we needed as well.
You need the saturate functions as well.
I've got the saturates, we just need the constants, I think.
Ah, okay, I see it. Ah, you need constants. Yeah. I missed them. Oh, sorry, my bad. Well, we learned how to save now. That is a good thing. So sometimes when I write for loops, I got into the habit now, because it's constantly compiling, to make first the program invalid, so it doesn't compile.
Yeah, save it.
Oh, did it save? I tried to.
No, I haven't got your constants yet.
I see that. Trust me, I've written it on my screen.
Let's do a refresh. Oh, there we go. Got them.
There we go. I don't know. It's probably because we have 3 people in this now, and it's confused by that thing. I think this is designed to be kind of a teacher and someone looking. And now I actually use a different computer system. So, and then we remove the specular color because we don't think that it's needed anymore.
Yeah.
Look how boring it looks immediately.
Yeah.
And now you have to compute the reflected array, and we came to the conclusion that the specular was doing that a little bit wrongly.
So we had specular, which was this reflect here.
Yeah.
Where did we do that?
Yeah, we can do it under a soft shadow. It doesn't matter so much. You know what they say, repetition is good for learning?
It is, yeah.
And then you have the reflective array, reflective direction. Vec3 equals.
Oh, that's right, yeah. I'm trying to remember what it was. Ref D, wasn't it?
Something like
that. Yeah.
and then you compute the reflected skybox.
Down here, wasn't it?
That you can do as well. Yes, you can right here get sky color. But also some people in chat, they weren't here from the beginning, so now they're
getting to see it all again. Yeah.
Yeah. If you start a rotation, do we see the suns? I think we see them. I think I saw them at least.
Yeah, they come.
Yeah, good. We can pause. Oh, my eyes hurting.
Yeah, let's rotate it a bit further, shall we? Go backwards.
That's also a very good thing about this editor.
There we go.
And then what you do is you reflect. You take the reflected direction and you get the reflected sky in under ref here.
Ref color we had, wasn't it?
Yeah. Sorry.
And that was get sky color again, was it?
Yeah.
Yeah.
And then what you do is you take ref color plus here. Now I'm going to show you a trick. Actually, I think I can introduce you to a trick here, which can be good.
Yeah, and then it was negative.
Yeah, and it's also too intense.
Yeah, so then we multiplied it by
0.3 or so.
There we go.
But I want to show we can actually do this in a different way here, which might be better. So I'm going to introduce a function here. Let's see if I can write this out, which is called mix, which is a very good function to know about. And hopefully I can do it from memory. That's always a challenge. So what mix does, if I type 0 here or 1 here,
right,
it linearly interpolates these things. So now we only see the reflected sky, and now we only see the diffuse reflection. So if you got 0.4,
right, yeah.
So yeah, so that's usually better to do that, because when we add things together, it's very easy to add up in a situation where we over add.
Yeah.
So we get values above 1, and sometimes that's what we want, but sometimes not. So I think this is probably a better way to do it. So that was a good thing it's crashed.
Yeah, let's just save that then.
Let's save it. Yeah.
We'll save every time we make a change now. We've learned our lesson.
Learned our lesson. And now you recreate this aggregate color thing here.
So I can't remember where we did that. We did it here, didn't we? So,
we did it. Yeah, you can write it here.
So I think we had something like vec3.
No, it has to be outside.
Outside the loop, yeah. So it was going to be up here, was it perhaps?
Yeah, under color.
There.
Yeah.
So there's three-dimensional vector, and we call it ag color. Go on, I'll go with you.
No, but we can go halfway, right? We can go ag col. That's kind of
ag col. There you go. So that was going to be a vec3 0.0 to initialize it, and then we were going to, instead of doing this, we were going to assign ag col there and there.
Plus equal.
Plus equal, you're right. And same here. And then down here,
and then you return
it here.
And now you save.
Save, and then we put the.
Yeah. So here's my trick I'm going to show you now. I put in an X here, because normally it's really good that it's compiling all the time, but here it's very easy to end up in a situation where the program actually crashed. But since I put in an X here, yeah, help me with the parentheses. Since I put in an X here now you can write a for loop, because it's not going to compile because it's invalid. And then we just make sure that the for loop is not infinite. These are the weird stuff you learn when you have these recompile and run immediately. and then you indent this thing here.
Yeah.
Now, I'm just going to check my phone a little bit. Or rather, I need to check my work Slack, because I have a little bit of tradition here, SMB, and that is I'm always on call when I'm on videos with you. So that is a tradition, and to sort of, not only can I screw up the stream, I can also screw up work.
Yeah, well, you got called out last time as well. Well, luckily we didn't stream on the Monday because I had those problems with my keyboard. But yeah.
So that is what I like doing. Now it looks like it's okay. This is just something else. So what does it say? So let's remove save.
Saved, yeah.
Remove the X.
Yeah.
It still works.
It still works.
But now you see it, if you change 1 into 2 into 1, you see what happens now is we aggregate the same point over and over again.
Yeah.
We're not doing actual reflection here. We actually are going in the same direction again. We're going to need we're going to need another value as well, and that is So what I'm after is this: whenever the ray reflects,
yep,
there is a ratio that is kept, that is the intrinsic part of the object and what the reflected ray is. And let's say that thing is 0.7. So 0.7 is 70% the object,
okay,
and
yeah,
30% the ray. Now, this is going to accumulate, because when we do the reflection again, in the other part, it's going to happen again.
Yep.
So this thing is going to sort of, this multiplication factor is going to be multiplied over and over again. And that is going to make the effect that the object is getting dimmer and dimmer.
Yes.
Reflected ray. So what you need, what you want here is a reflection factor, or whatever you want to call it, right? Something. So you just make a float that says
a float.
Okay. Which is reflection factor. I don't know what it's called, the math, and let's say it's 0.7. So we keep 70% of the object, but then you have a reflection aggregated factor or something like that. That is, that we're going to increase, we're going to multiply each time to sort of dim out the object.
Yeah.
If that makes sense. And this is going by memory, right? So it's so you need another float. So it's kind of ag version of this thing here. And that starts at 1. Because at the first iteration, it's the intensity is the intensity, right? Something like that. Now we're getting here. Now we're starting to get to a point where we want to be. So how do we do in the next step? So what we do, so if you scroll down here in this render function, now the problem here, if you increase this to 2 iterations, the problem we're having here is that we are starting from the same point, but whenever, so what we can do here actually to make this more behaved is you actually, when you do the ag color here, you multiply by this aggregated reflection vector. So we sort of, we scale it down for each iteration. And it's not going to help right now, but it's going to help later.
Okay.
What did you call it?
Ag reflection factor. That's correct, I think.
Yeah. So.
Did I put
no
R?
You have an R here, right?
Yeah, get rid of that.
But it's still not correct.
Okay, because there's no F either.
Okay. And then you copy paste this thing and put that in front of the sky color ray intersected as well, right? And what we do now, after each iteration, is that we multiply this part. I'm thinking. Sorry, I need to think a little bit here.
It's okay. We need to adjust the aggregated reflection factor because it's currently a constant, isn't it?
Yeah. So can I?
Yeah, you carry on. Yeah.
Yeah. So, and it's not because I'm kind of old and lame that I do copy through a menu here. It's more like if I do it using keyboard shortcut, I know how to use keyboard shortcuts.
It doesn't work, yeah.
It doesn't work. So I just want to point it out for people that have this. Why isn't he using the keyboard shortcuts? Wasting my time. And now we have to find a. Let's see if I can do it. Nope.
I'll do it.
The multiplication sign.
There you go.
Yeah. And then I suspect that we got to aggregate this as well.
Yeah.
You copy that thing and paste it to a new line.
Oops.
No. No, that was wrong. You want to have that thing. That it was, but you want to copy that thing and paste that into a new line. That it's too long for me to remember. No, not like that. Okay, I do it. I'm bad at explaining this part, but I think it's going to be pretty obvious when I do it. So undo this thing. And this we're going to multiply. Yeah. So can I get the multiply equals? And this is going to be multiplied by 1. See, I find one thing.
You found the negative sign, yeah.
Yeah. So what happened here now is we multiply this. We keep because we're going to multiply out. It's probably okay. But this factor here is going to be diminished by each reflection because when we make a reflection, we want that to be dimmer. So this is going to become closer and closer to 0. And this part is sort of, how much of the material we keep.
Yeah.
What we have. So this is the kind of reflection ray. With recursion, this will be much easier to understand, but we don't have recursion, so we kind of have to do this kind of weird stuff going on here. But it is to handle the reflected values, and then we need to diminish this part. So because this is the intrinsic part of the object we're looking at, we have to diminish this by the reflective part. So if we have, we're just going to code ahead, and I think it's going to make sense. So what we do now here, we need to update the ray origin, the point where we're standing. And what is the because when we're having the reflection, we're going to do where are we? Where is the observer?
Yeah. Well,
observer is on the surface. So, and we have a point that is on the surface, and that is this point here. So if my guess is correct, what you do now is you just say RO equals pos. And then you say, then we need to have a reflection array as well, because now we're going in the same direction as before, but we not want to do that. We want to go in the RD should be the ref D. And then I also think, because we are actually now intersecting the point here, I think we can make a little bit of adjustment here to this function here. Get sky color. The function I'm looking for is this function here. So if we do here, Okay, something happened.
Oh, look at that.
Is that correct? Is the question.
Who knows?
Yeah, but so what happened here? What I try to do here is like, because we are standing, the reason nothing happened was because we were actually we have intersected the point. So what happened? The loop didn't loop a single time. So now we actually start a little bit from the region, and then it will traverse and try to find it. Let's see what happens when we start the rotation. When we add motion, it can sometimes be easy to see if things works. It's well, I actually think this looks a little bit like a reflection, right? Yeah. We see the white surface here.
Yeah.
We see the sky and yeah. And this is the shadow. The reason we don't see anything is this is the shadow. That's why it's. Okay.
It is. Yeah.
The shadow. No, but when we are reflecting in the shade, the reflected ratio should still be there. So the shadow shouldn't sort of
block everything out. Yeah.
Right. So that seems wrong. So that is probably a bug. But it seems in my eyes that we actually have a reflection here going on, even though we have some bugs. That's pretty good, I think.
Yeah.
Right?
Yeah.
So I think it's easier to tell if we actually add two spheres that are beside each other, because then we can see the spheres reflect in each other.
Okay.
But an idea we could do, right, just to see if the shade is confusing us. Let's see how we compute these things here. So here. So we're having the mixed color here. Thinking. Let's. I'm gonna try something.
Okay. Interesting.
It looks a little bit better.
Starting to look more like a chrome ball, isn't it?
Yeah, this part looks a little bit weird.
Yeah, very dark, isn't it?
There's something wrong here, but there are parts that looks right as well, right? In my eyes.
The reflection of the white surface here looks right.
That looks right, and so there are things that looks okay, and there are things that doesn't look okay. I increase now, so you have multiple reflections. Yeah, we are doing something a little bit fishy, but let's add a sphere. Oh boy, it's quite intense, right?
It is very bright, yeah.
So I think we're doing something right and we're doing something wrong, but that's how these things goes, right? We are seeing, I think, the box here.
Yes, that's definitely a reflection of the surface we've got here. Yes.
Yeah. So that's good news. So let's make the object slightly more complex. Let's add another sphere, and we can see them. Try to see if they reflect in each other.
Okay. So that was.
So if then you go up into this distance function we have above here.
Can't remember where it is.
It's here, distance function.
Oh, distance estimator. There we are. Yeah.
So what you do, you keep the box. The box is good.
Yeah, you want another sphere. Yeah.
Yeah. So what you do is you make maybe call this S1 for sphere 1, and then sphere 2. And you want to offset them from each other.
Yeah.
So let's make them a little bit smaller because now it's quite big. So let's make that 0.7 or something like that. And then what you do is you take P minus, no, inside the sphere, sorry, I wasn't clear. You want to offset them. So you take P minus, vec3, 0.7. Yeah, that's probably, no, that's not good. 0.7, yeah, comma 0, comma 0. So this will offset the sphere. And then you take this, you copy paste that line. No, sorry, the vec3 part. Sorry, I wasn't clear. Copy paste that. And in the other sphere 1, you go plus instead. And then you type float D. So now we want to combine these two shapes. We take the union, and the way we take the union, we take the mean function. So then you take mean S1 and S2.
There we go. Yeah, we got 2 of them.
Yes, let's rotate this and see if we can spot the other sphere in the other. I think we see the other sphere, right? Don't we?
There, isn't it?
Yeah. Let's increase the count again. Stop it. There are bugs here, for sure, but there are also things that are working, right?
Yeah.
So let's increase the reflection count to 3. Yeah, so you see the reflection, and then you see the reflection again. So that's good, right?
Yeah.
Don't you agree?
Yeah, it's getting there, yeah.
And so what we're having here, one of the things we are struggling with, which I don't understand at this point of time, is keep it at 3.
Yeah, I was going to save it at 2 because it was,
so 2 things I'm struggling with here, right? One is this weird black thing here. I don't understand where that's coming from. But that's solvable somehow. I also wonder why the intensity of the light increases whenever it increases the reflection count, because the purpose here...
It should be decreasing, shouldn't it?
Yeah, the purpose here was of this reflection factor was that should actually decrease the intensity each time we reflect, because we are multiplying by this part here, right? So that is what's confusing me a little bit here, if I'm being honest. So we can change the code. Let's say, by the way, you never know if I manage to screw this thing up.
Saved.
Yeah. So if I change this to 0, the reflection should disappear in my head.
Yeah.
And I lost
it. And it does, yeah.
Well, not completely. It's still gray.
Yeah.
Why is it gray? So this is something I think. But if we solve these things, because we see here. It could be. Oh, yeah. You know a problem here. I see a problem. We don't need this part anymore.
Right, yeah.
That is redundant.
We've lost your audio there a bit, Mårten.
Sorry?
We lost your audio there.
Yeah.
Shall I comment that out?
Yeah, remove it. We don't need it anymore.
We don't need it.
Because that was the cheap way of doing reflection. But we are actually we're getting this for free, and ref color as well. And now you have to remove the ref color inside here. And remove the mix function.
And we got ref here somewhere else.
No. 0.4 is wrong as well.
We just need to get rid of this one here.
And the comma is wrong. Multiply by. There we go. Refdir. The refdir is needed. So
yeah, it's not undefined at the moment.
That was a mistake. But let's just write it again. It was the ref color I wanted gone. So, but that's simple. That was not a hard piece of code. Spec 3 refdir.
I can't remember what it was. Do you remember what it was?
Yeah, I don't know. But I was in the United States. It was called Mårten Rage occasionally. I like that. So you go reflect.
Hello, Sled USA. Welcome to the stream. Okay, and it was reflect. Sorry,
minus LD.
Yeah, minus LD.
Yeah, I'm about to point it out later. Comma the normal.
No, yeah.
And then it's not reflect, and it's reflect.
Oh, this is a code-based alpha stream. We can't not have spelling mistakes.
Yeah,
that's part of the deal when you go to the stream. Okay.
And then what we do now is I'm going to write here.
It's catching, you see that.
I'm surprised by the gray background. Because you see, now we get here. That's good. Ah.
Thank you very much for the follow. Excellent. Thank you so much. That's really, really kind of you. We do normally have some kind of hype that goes around. Actually, I don't think it will work. We'll give it a go.
So I'm trying things a little bit random here now to see.
No, we can't get the hype going. I'm sorry about that, but normally when we're on the not on pair program, you give a nice hype shader that comes in, but it's on the other screen, unfortunately, the scene. So.
And also, we are doing reflection, so it's a little bit more high risk than usual. This thing here.
Yeah.
So add the multiplication sign. I can't find it.
Yeah, there you go.
So I think this was an improvement, but there are things still not right. There's still things that are right, but the background is now gray, which is surprising.
Yeah, the sky color seems to have gone away.
But start the rotation again, because sometimes that helps us see. We see the sky being reflected.
Yeah, you can see the sun there. Here's the sun coming in now. Look, so it is there.
Oh, yeah.
But it's extremely large. Maybe this is the problem. It's very, very big and very, very bright. Maybe we just scale it down.
It's interesting why it is, right? Because let's see now. So did we do something with that function, or?
I think last time before we commented, we comment some stuff out in the Skybox, which is now back because we got that crash. We get sky color.
Yeah,
I think we might have.
Let's reduce reflection to 1, so we just have one intersection. Okay, and then you go 2, and then it gets more intense.
Yeah, very much more intense, and it should be diminishing, shouldn't it?
Yeah, that's what I'm thinking, right?
Mm.
Oh no, we need a break. That's what we're missing. We need to break stuff, right? Because there's no use reflecting if we hit the sky.
Ah, so reflecting the sky, are we?
Yeah. So that's what we're missing here. We need a sort of a break condition. So that's an obvious mistake, but that's what you get when you watch live streaming.
Yes, Cody Bid, it's a supermassive star. It's not unlike the star that we're orbiting at the moment, actually, on the code base, but That's actually a black hole, but it does shine quite brightly like that because of all the gamma radiation and X-rays.
I'm looking a little bit. Oh yeah. It's very okay. It's not so hard. Yeah, semicolon. There we go. Now we're getting there.
Yeah, it's looking better.
Yeah, but, so what we do now, when we hit the sky, we just say, okay, let's break this loop. We're not going to get any further. This is uninteresting. What we did before was like, okay, we missed it. Let's go again.
Carry on, yeah.
So let's add rotation again and see how this looks.
I think this source of light from above, this very, very bright source of light is possibly an issue.
Well, I think, it's an issue, but it's easy to remove. So what you can do now is you go up into this Skybox and you comment out line 137, 138, and 139.
I think this is what we did last time.
We did that.
Yeah. So now we get in a much... Yeah.
But we see the spheres, right?
Yes.
That's good news,
yes.
In my opinion.
So should we add some more reflections and see what happens now?
Yeah, increase the reflection count to 3.
Yeah.
So now you see the sphere reflecting in itself. Let's make it 4. Yeah.
It's reflecting down here as well, which is really nice. So this has become a reflective surface as well.
Yeah, so we're getting there.
And is this the spotlight we've still got on there?
And the spotlight is it's the sun.
Yeah.
So before we did Phong shading to get the spotlight, which was kind of it's not the right thing.
I was wondering what this one is. What's that one there?
That's the yellow sun. There's 2 suns.
Oh, there's 2 suns. Okay, right. That explains it.
Yeah. So now we see the reflection of the yellow sun. So the only thing really that surprises me at this point of time is this black darkness, because what we should see there is actually
reflected
the
light. Yeah.
Yes.
To answer your question, Cody B, yeah, I did watch the Starship presentation. Couldn't watch it live, unfortunately, so I had to watch it the next day. It was a typical Elon Musk presentation, but made so dramatic by the backdrop of the Mark 1 test vehicle. So I really enjoyed it.
Now there's kind of a subtle reflection in the.
What did you alter?
I think we have. Sorry.
What did you? The reflection factor you fiddled with? Okay.
Yeah, I think we have some bugs here, but I mean not overly bad bugs, because it kind of looks okay, right? So let's review what we've done here.
Okay, yeah.
Maybe I can understand what's happening. So save it. It's a good start. So we took the code we made the last time, right? Where we had these balls, but they were not reflective. And what we've done this time is saying, okay, let's take this thing here, but instead, to add reflection to it, we add a for loop. So we are going to so we find the intersection of something, but then we're going to iterate from this point here. We update the ray origin to be the position where we intersect the sphere, and then we change that the ray direction we're going to walk along is the ray direction.
Yeah.
So that is kind of what we did, and then we did the for loop on this thing. So I think if you think about it, the changes we've done is quite small, actually.
We haven't changed much, really. You just added the nice sky, and the rest of it's just been the same. Just a few.
Of course, we have some bugs in this thing, because it's very easy to create bugs here, because I think we have an issue here in that. But the result is we see the sphere here, and we see the reflection of the sphere again here.
Yeah.
So we're actually having real-time reflections using ray tracing. I think that's pretty cool stuff.
Yeah, and I think it's worth. I mean, we probably kind of say this every time on these shaders, but these aren't videos. They're not. They're all being calculated on the fly on my GPUs. So every 60 times a second, many tens of thousands, if not millions, of floating point calculations going on now in parallel.
We are likely up to teraflops.
Yeah,
that's usually
astonishing.
Because you have 1920 times 1280 times 60 frames per second. That's a large number.
Yeah.
Then we do. I don't know. I think we have 60 iterations in the ray marching loop. We are looping up.
Yeah, quite a few iterations. Yeah.
We do quite a few iterations. 60, I think it's 60 iterations. 60. So there are 60 iterations. And then we repeat that thing 5 times for the reflections.
Yeah.
And then we do a lot of floating point operations inside all this thing here. And the end result of that number is very, very high.
Yeah.
So I think teraflops here is not unthinkable.
It just goes to show how powerful your GPUs are.
Yeah. Incredible. But what's also nice about this programming model, and that's also we discussed before, is we are actually programming like a single-threaded program here. We're sitting and writing a program that takes a single coordinate of a pixel, and from that thing we're implement a ray tracing into some kind of mathematical object, and then we compute the reflection. Boy, Coded Beard here is...
what happened there, Coded Beard? Was that a link? Sorry if you posted a link.
Yeah.
I'll sort you out.
Yeah. While you're doing that, I'm going to review one of my older examples I have here and see if I can see something obvious that we're missing, if that's okay by you.
Yeah. So I've made you a moderator, Coded Beard, so you should be okay.
I think we made a huge mistake here.
Have we?
Yeah.
So post your link again, Coded Beard. I'm really sorry about you being timed out.
That's a pretty made one. I don't know why we've made such a huge one. Now it looks much better.
Oh, we were using LD, okay.
That's a weird...
There we go.
It kind of looked key anyway.
Yeah.
But okay, but now it looks good, right? Don't you think?
We got the chrome effect now, yes, and we got the spheres are now below the plane of the box, aren't they?
So the bug, which was very simple, you saw I just changed 2 characters. We reflected the normal and the light direction.
Yeah, rather than the ray direction. Yeah.
I mean, we copy pasted some code. That's our problem, right?
It always is.
And now it actually looks. I think it looks like it should be looking for this thing. I think what we should do now. So what do you want to do, SMB? We got reflection working, and it looks, I think, in my opinion, decent.
Yeah, absolutely. Well, we were kind of heading in the direction of refraction as well, weren't we? So is there something we can do with this, with some refraction as well?
Before we do that, I would say we're going to introduce materials.
Okay.
So what we can do is we can try to make this reflection factor we're having here, instead of that being constant, because how much a surface reflect is sort of, you know, is attributed to a material. So what we can do now is we instead saying we should get the material that we intersected, and then we have different reflections. So maybe we want that this part here shouldn't be as reflective as the
balls. Yeah. So Coded Beard, I sympathise with the cost of your 2080. I've got a 2060 in my machine, but I bought it as a complete machine. So, but a 2080 Ti, but they are a bit expensive. So you're saying that given that the GPU is easily the most expensive bit of your rig, hope you can do that many? Yes, well you would hope that, but it's still pretty mind blowing, isn't it, that it can do that?
But also, what I hope Coded Beard with this stream here is that kind of that show, it is the most expensive thing you have in your machine, and it's actually quite simple to program and get cool stuff out of it. So that's what I'm hoping for in these streams, that people are not buying a lot of hardware. I think most of us in this stream are programmers, right? And we love programming, most of us. And we have an enormously powerful thing in a machine that we can program.
Yeah.
So let's do some programming on that stuff and do stuff. Does work? Yes. Ow! I hurt my knee. So, how do you do materials? Well, I'm going to do something I've never done before in this thing, but I think that's the fastest way to do materials.
Let's do something you've never done before. That sounds great.
Yes. And now I'm a little bit afraid we're going to see the view count drop here, right?
Yeah, well.
I'm going to suggest we use global variables.
I'm choking.
Yeah. What's happening here? What are we talking about? And global variables with threading, that goes against everything you ever learned about threads, because here we have a GPU which has a lot of threads. But the cool thing about the GPU programming model here is that for us it looks single threaded.
Yeah. And
in a single threaded program, a global variable, while not cool, or it works, right?
Yeah.
So what we're going to do now, if you go into your distance function, the one above, here. So above here, you're going to add a global variable that we call float. Yeah. And soon I'm going to do a goto as well.
You're teasing us now.
And call it underscore reflection factor, or whatever you want to call it. Equals 0. Something like that. And the way we do it now, so there are different ways of approaching this thing here, right? But let's say we want to do this thing that when we have intersected the box, we want to have a different reflection factor than we intersected the sphere.
Yeah.
Let's say we want to do that.
Yeah.
So how do we do that thing? How do we know we have intersected the box? Well, it's actually not that hard, as usual.
Because it's there, yeah.
I mean, it can be a little bit hard to sort of figure out the first time. I don't know what to call it. O as in object. So O is the distance to the object, to this full object here. And when that is 0, it means we have intersected the object.
Yes.
But we want to distinguish when we intersect the box and the spheres.
Mm-hmm.
And here, this is the distance to the box, and this is the distance
to the pair of spheres, yeah.
So what we are going to do is saying, if parentheses. I'm going to tell you, if O is equal, equal to box.
Oops.
Oh, not 0. Yeah, that's too funny. Then you say reflection factor equals 0.9, perhaps. Else? I've never done this before. This is a first for me. Because
0.7 still?
0.3.
3. Okay.
And yeah, in 0.9, yeah, that's probably good. Reflection. You're missing an L, I think.
I was consistent.
Yeah.
I like Dragon Eyes program. That's my kind of programming. 10 print hello, 20 go to 10.
There we go.
It's Gareth raiding with a party of 59. That's absolutely incredible. So thank you so much, Gareth, for that raid.
Gareth has been racking up viewers last
He certainly is.
Last time.
Certainly found a fantastic audience. So welcome to the stream. If you're not watching ads, we're working on shaders. We're working on reflection at the moment. So we've got these two reflective spheres above a reflective surface, and they're rotating around. Well, the two suns are rotating around them, or effectively in the video, or in the shader we've got. It's a yappy dog raid indeed. Thank you so much, Gareth. So we're currently looking at. Sorry.
Yeah, I was watching another stream. I forgot his name. He ran into the same problem Gareth had a few weeks ago. That he got a lot of bots.
Yeah, that was the Michael Jolly stream the other day, wasn't it?
Oh, yeah.
Yeah.
That was annoying because I was just following and I couldn't comment. The stream, I was very frustrated.
Yeah.
I thought I had some witty comments as usual, but maybe it was me he was blocking. So you can comment this line out. Yeah. So instead of this, you put in an underscore reflection factor here, right?
That was down here.
And also save is probably a good idea here.
Yeah. There we go. Yeah, so we've definitely got the different reflections going on.
We got different. It didn't really work as I was hoping to.
No,
to be honest,
it looks a bit weird.
Yeah, it looks a bit weird. Well, I guess that's what we get for using global variables, right? Let's think about that.
The interesting thing is it's very reflective in the shadows.
Yeah.
Which is interesting in its own right.
Yeah. Well, maybe the global variables wasn't such a good idea in the hindsight, but maybe we can make that work. I mean, something happened, and that's also what I like about shader programming. That you do a little bit of programming, and weird stuff happens, and that's okay.
It's all part of it. We can now have fiddle around and see what changing things does.
Yeah. Bye there, Gareth.
No problems, Gareth. See you later. I'll catch your stream when I'm not so busy at work. It's been manic.
If O equals the box. It should be like that, right?
Ooh.
Now it's kind of the opposite. Let's experiment a little bit.
Ooh, interesting.
Yeah, that was. It seems that.
Yeah.
Yeah. Global variables. Maybe it wasn't such a good idea after all. I need to review my old code if that's okay by you.
You carry on, yeah.
Because I mean, we can sit here and figure it out in details, but it is a stupid thing that is happening here, and then we spend a lot of time trying to figure it out. Well, the code actually looks okay. The only difference really is the use of global variables.
Hello, Mickey Rose. Welcome to the stream.
Yeah. So okay. So if you're not using global variables, we will have to do it a little bit differently. Yeah. And I was kind of hoping to sort of avoid that, but maybe that is what we need to do. So shall we global variable this thing here, right?
Yeah.
Is that okay by you?
Yeah, absolutely. Yeah, I'm going to go down the bottom and so it was. We wanted to reinstate reflection factor.
No. We keep the code.
Okay.
For now, while we are refactoring it.
Right.
And then save this thing here. I'm disappointed. Global variables failed me.
We can remove our gasp now, can't we? We're not going to use it.
Yeah. I'm going to change this to 0.3 to start with. So I just need to have a look here. Maybe it's because, but it shouldn't be that. It should be. It's not like it's inexact because the mean operation. Well, what we can do is to do we make the comparison a little bit fluffy. Oh God. Yeah, I need a lesson sign.
There you go.
Yeah, that didn't help. The thought was good.
Yeah.
Didn't work out. Global variables. What did we learn from this thing?
Don't use global variables.
Yeah. If it doesn't work anyway, then it wasn't it. Okay, but the thing I usually do when I'm doing this thing is I introduce an out variable that I call the float ref, and then I instead of using a global variable, I set ref equals this thing here, and ref equals that thing there, right?
Mm-hmm.
But now the drawback with this approach, and I was kind of hoping to save time on the stream by using global variables, but this, this. Christ, can you?
There you go.
Yeah. Now, what we want is that the Raymarsh function here, right? It returns also the ref here. And then this thing here, right? Now, this function, it also requires a ref, but here we don't really care about what the ref comes, because the purpose of this function here is, can I have a semicolon?
Yeah.
The purpose of this function is to compute the normal.
Yeah.
For viewers that weren't here the last time, this is an approximate way to compute the normal using what's called a distance function. And the normal is very, very important when you do Raymarshing, because that is, that helps you do the reflection. But now when we added this parameter to the distance estimator, we need to add this in all places, even though we don't care about the result.
So Dragon says it says if duct tape isn't work, you're not using enough duct tape.
Well, that's when it comes to
Galo,
shaders,
thank you so much for the follow. A salute from Alf there. So we haven't got our hype shaders aren't working on this particular scene, so I'm sorry about that.
That's because your GPU is working. It's
overtime at the moment. Yeah.
Yeah. Look at that! I got the semicolon. I'm a real programmer.
There you go.
So I'm just refactoring code here, and hoping that now float ref. We will call this float reflection factor.
Yeah.
Right?
Mm-hmm.
Reflect factor. We all misspell this.
It's catching. I tell you, it's catching. You get that back from the Raymarcher, yeah. Oops.
This is the SMB effect.
It is.
I'm usually very good at spelling. Yeah. I'm lying. And then I'll use this thing here.
Interesting.
Yeah. It looks more consistent.
It does. So we've got a high gloss finish at the bottom. Then we just need to kind of reverse that so that the spheres are the high gloss ones, aren't we?
I mean, it looks, before it looked weird. Now it looks not how we wanted it, but that's, in my book, that's an improvement. And the best part is, if you learn from this thing that never use global variables, imagine now we have a data point.
Well, we have absolute proof never to use them now, don't we? So we can quote this. If you change that D to box, what happens then?
Yes, I think that's exactly what we're going to do.
Yeah, so now we've got a less reflective sphere.
But you see, there are reflections here, right? But they are much fainter.
We probably want to increase it slightly so we get a bit more of effect, but it's certainly there.
So what did we achieve here? We introduced a very simple material thing into our world. So this object here is less reflective than this object here. Now, we can also add something which is called the Fresnel's law, which is cool, but we're not going to do it today. But what Fresnel's law say is when the ray, how do I explain this? If you're looking at the surface, when you're looking directly down into the surface, it's less reflective than if you're looking and the surface is almost like 90 degrees, or like your eyes is sort of following the surface. If you, do you understand what I'm meaning?
How do you spell the name of the person whose law it is?
Fresnel.
Is it 2 S's?
What happened now? I did something.
I'm not sure. Don't do that, yeah.
I'm gonna write it in the magic Fresnel's law.
Did you put it in the code share, did you?
Yeah, I did that.
Thank you so much for the follow, Quasi, I'll call you, Quasi Kiri. So I'm going to use our bot to see if we can get some information about this. So we're going to use the exclamation point ask command. We're going to say what is Fresnel's law, and see if it comes back with something. There we go. So Fresnel equations, or the Fresnel conditions deduced by Augustin Jean Fresnel, describe the behavior of light when moving between media of different refractive indices. The reflection of light by the equations predictor known as Fresnel's reflection.
Well,
there you go.
I'm going to share a link with you here. And maybe because I have some pretty good pictures, or at least a decent picture, if I can find a code share. So here, Fresnel's equation.
Go and have a look at that. We'll go there.
New t-shirt. So if you see these two pictures here, maybe you can click one of them. You can click the water. It's very relevant when you want to do realistic water effects.
Yeah.
So the thing about water, if you look directly down into the water, it's transparent. But the further you lift your eye towards the horizon, right?
Yeah.
It's more and more reflective. So when you look down in the water, it can be kind of greenish because you see the color of the water and the color of the bottom. But when you look towards the distance here, the angle, the normal is pointing up, and the incoming angle is almost perpendicular to it.
Yeah.
And that means then there's that almost all materials then shows the tendency that the more perpendicular the incoming ray to the normal of the surface is, the more reflective is the surface. And this is totally possible to program into what we've done.
Right.
Is to do that, because then the surface, it actually adds a little bit of sort of realism to the surface, because the reflective index change depending on the normal and the distance. But I'm not sure we're going to do it today, but I was going to mention it, that it's possible to do that.
Because at the moment we've got almost kind of perfect reflection, isn't it? These are kind of perfectly reflecting spheres. Then
well, they're not really perfect, but let's make them perfect.
You know what I mean? They're yeah.
But then they look a little bit weird. Yeah. So I mean, I think we can be pretty proud with this.
Yeah.
Don't you think?
Yeah, I do. Yeah.
Let's make. We can make the. Yeah. I mean, we can make. Let's make some cool stuff now, right?
This isn't cool enough.
Nah.
Not cool enough. Okay. Let's save what we got.
So. I think it always helps adding a little bit of motion to things to make it a little bit cool looking. So, and a good way to add motion, can I have a multiplication sign? It's hard. This is hard. The sinus function is always good.
Rito says it's not cool. Not cool enough for him, so we can get cooler.
Well, I'm trying my best here.
Yes, the eye time is for when we go to shader toy, isn't it? There we go. So we now got Newton's cradle going on.
Yeah, but let's use the soft mean function because that is much better than the boring mean function. Don't you have the soft mean function? Did you remove the soft mean?
No, it should be there somewhere.
Where's the soft mean? Can you look around for it?
Yeah,
because you had it before, I'm pretty sure.
You definitely did, yeah. S-min.
There it is. S-min.
Yeah.
You went to my naming standard.
Oh yes, we just reduced it down to the absolute shortest it could possibly be.
So let's go up to the distance function here. And we change this into soft mean.
Yeah, and then we got the soft collisions. That's lovely.
So let's take that a little bit slower. But you see reflection, everything works here. In this surface. So do we have a box? We have a box function. A thing I sometimes like to do when I do experiments is create. So one thing that is cool. So now we've made this reflection. So now I'm just going to improve improve. I'm not sure that is the right word, but I'm going to change. I'm going to change the object we're looking at.
So Bacon Drinker has got a question in chat.
Yeah, sorry, I'm totally absorbed by
welcome to the stream, Bacon Drinker. Thanks for your question.
How is the shader controlling movement? Now that is an interesting question because I don't really understand that thing. So what do you mean by how is shader controlling movement?
I think it may be a slight misunderstanding of what the shader actually is doing. There isn't any movement really. Is there? The shader is just calculating the color of a pixel, but we're just doing it over this entire canvas, 60 frames a second.
So maybe Bacon Drinker. I'm sort of now extrapolating a little bit from your question here. Now we don't do triangles here or these kind of things. We don't have objects in the normal sense when doing graphics. We actually are more like in a world where we're dealing with mathematical objects. And the function we are seeing here is what creates what you're looking at. This is what we're seeing on the screen. And on the screen we have a sphere and a sphere. But this is actually just mathematical objects. That's more like, that is the distance to a sphere. So in order to get this movement here, we have a position here. This is the position where we are currently in the ray tracer. But I'm just adjusting this offset here and taking the sinus function and using the time. And the time is changing over time. So because time is moving, the object will then change. And that gives this sense of movement in the object. I don't know if that makes sense.
So yes, the distance is changing because we're multiplying the x value or whatever the first should be the x value in the vector there by the sign. So the sign is going to obviously move between plus and minus 1 as the time changes. So it's just varying that to it'll be either 3 or 1 as its extremes.
It's very easy to hit that button. I don't like the button. I'm going to change this to a big number. So even if I hit that button. So, but what I want to do now is I want to.
Does that answer your question, Bacon Drinker, or is it just still a bit confusing?
It's an easy way in math to make it go around the others in circles. Yes, there is. I can do that for you, Vitlol. I think what you're asking for is.
You want an orbit, I think, don't you?
You want an orbit, right?
Yeah.
But now is now we come to the hardest part in the whole stream. I need the multiplication sign.
I wasn't there watching you back there. I was watching the stream. So now we got the Death Star orbiting another Death Star.
Yeah, and now, you know, just to spice things up a little bit here, what we can do is we, you know, because we want to have this.
Multiplication.
Multiplication signs. I need to learn them sometimes. Can you get me multiplication sign? Yes. And here as well. Thank you. That looks pretty cool. What do you mean by orbiting vertically? Bacon drink.
I think you want it to rotate in the Z plane as well.
Upwards.
Yeah.
Is that what it's? Well,
I don't know what on earth it would look like.
Do it like this.
Give it a go. Now it's going to. Oh, that is interesting. It's now dipping inside. Oh, yes. Quite bizarre.
Very mathematics, these things, yeah. So, but it's great we're getting questions from the stream.
Yes, thank you very much for the questions. Yes, it's.
And also, what's cool about this, we don't recompile; it just happens immediately.
We save that effect. That's quite like that one. Let's save that.
What about each sphere rotating again around?
Oh, they're really asking for stuff now.
Oh yeah. Well, you see, now we're getting into my consultancy here, right? And
you start charging me.
My rates are this. No, but we, of course, we have to please the cloud, don't you think?
I think so.
So for people that don't know, I don't use an English keyboard. So I have a different keyboard. And so my mind is kind of programmed into a different.
What would you like?
So but I think interesting questions. But I think what I wanted to show you was something that you will find interesting. So let's do this. Let me show you something, and I think you might find it interesting.
Go for it.
Yeah. So we have a box here, I think, right?
We do have a box, yeah.
And we make a box. Now we can see how this interacts with the box instead. And you know, because we are dealing with distance functions, everything works really. It's nothing strange here. We don't do anything. So I think that's also quite cool. But a thing I like to do is boxy that are holy, like that have a hole in them.
Yeah.
So I'm going to call 0 here. And now we are going to do Boolean algebra, but with shapes instead.
Yeah. So this is really interesting stuff. How this works. So we did this with 2D. On the very first stream, we did the Boolean algebra with the 2D shapes. So now we're going to go in 3D with it.
So how do we create a box that has a hole in it? Well, we subtract a sphere from the box. Is one possible answer to that question. So if I take that back here, and then we go max 0 minus. You see what I'm saying here?
Yeah.
We have created now a box that has a hole in it, which is also reflective, by the way.
So don't you find that absolutely amazing that just that one line of code, and now you've got a completely different shape, which I think if you were working in triangles or anything traditional, you just have no way of doing that.
And here it's quite interesting, right? Because when it's actually inside here.
Yeah, it fits in there, doesn't it?
Yeah. So let's move the viewpoint a little bit closer so we can study the beauty of the reflections. Yeah, you can see the reflections here, how they go in and reflects into each other, right? So it's it's pretty cool, I think. And you see how the material reflects in itself. You see it's coming here and here and here. I think we've done pretty well, S&B.
I think so.
And it's how many lines of code do we have here?
Not many. 230 with a few comments.
But it's 200 lines of code, and we have a ray tracer that supports reflection, running in real time, and not using global variables.
Yeah. Imagine you thought you'd have to use a global variable somewhere to get this, wouldn't you?
I was thinking, let's save some time there, and then instead I wasted time, and that's exactly what happens when you use global variables.
Yeah.
I'm gonna make this sphere a little bit smaller, because I think that's gonna help us see a little bit clear what's happening. And then we can make the yellowing effect a little bit more extreme. Not that extreme. Yeah, not too bad, I think, right?
I think it's pretty amazing, especially when the sphere goes inside the box.
Yeah.
How far can we take the method of rendering bacon drinkers?
Now
we can start to show some stuff off.
I think it's now. I think we can. I have an opening to show the shader I made. If you agree, the terrain shader I showed you earlier.
Terrain shader. Okay, we'll go and look at that.
I'm not saying this is the maximum, but this is as far as I got.
So we'll save that away to make sure we've got that. So let's go and open up.
We don't want to lose this code.
Go and find.
I was just waiting for this thing here. So it's called terrain.
There we go. So this is kind of how far you can take it. So we're going to.
This is, but let's type in 108, perhaps. Yeah, try 108. This is a mountain edge, and this is completely computed using math.
And we're going to do a stream. One of the future episodes will be around about developing terrain and water.
Yeah, but there are no assets here except a random noise texture that I'm using. Everything else here is kind of done through ray tracing and similar technique here. So I think you can take it quite far, to be honest. And there are some really good examples on Shader Toy. This is Sitecode Shader Toy, and they show really cool stuff, and where you can really sort of that makes this looks kind of lame. Now, where the texture comes from? So the way this thing works here is I use this concept of different materials. So the mountain itself, I generate from this random noise and sort of overlaying this noise. This is called FBM. I don't know exactly what that name stands for, but you take this random noise over and over again, and then you get a mountain range that looks like a mountain and has normals like the mountains. But then I use different mathematical techniques to sort of get the color to look like mountain, and also to to get sort of banding in the mountain.
If you look closely at the mountain, you do see kind of some the strata in the mountain.
Yeah, and then the snow on top of this mountain is actually just a height, that everything that is above this height combined with a certain, that the normal of the slope influences the snow. The trees are generated called something a Voronoi pattern, which is a very simple pattern, but it has the benefit to look organic. But it's a very simple mathematical function that allows you, the reflection is quite nice.
The reflection is amazing, yeah.
Yeah. So, but it has the benefits to look organic. If you would to zoom in on the trees, you would see, these are not real trees. He's been cheating. But that's why we are not zoomed in here. You know, when you do these kind of ray tracers, you are cheating to get the results. So if you have, for instance, the water here is flat, but we don't see that because the normal is computed correctly. So it looks like there are waves on the water, but the water is actually flat. So there are lots and lots of cheating to sort of get results that looks okay-ish. The sort of the fog generation here as well is just pure random coding. I just tried the thing, it looked good, I kept it, I didn't think about it anymore.
Here's the strata you can see here. Look, it looks quite natural that this mountain's been built up.
Yeah. But that's basically what that is basically a sine function that I powered up a few times to sort of make the peaks more intense. And so it's math-wise, it's not very hard. But it have taken me a long time because there's a lot of trial and error in this thing here. If that makes sense to you.
I think Bacon Tree, because that's one of the things that I've kind of picked up over the last 3 streams, is that you start off simple and you just layer things on and you try things, and you, most of the time, as we found today, you do it wrong and it looks rubbish, but you learn something from that. You keep tweaking, trying different things, and eventually you start getting the interesting effects. And I guess you learn from other people's ones as well.
Yeah. I mean, Shader Toy. If Shader Toy didn't exist, because I started with this. I mentioned to this you before the stream, SMB. I started with this thing 1 year ago, approximately. I knew nothing about this 1 year ago, and I haven't really been working complete on this. I've been investing some time to this. But if Shader Toy didn't exist, with all the examples and all this cool stuff you can find on Shader Toy, I would never been able to do this thing here.
It's a very generous community, isn't it, over on Shader Toy?
Yeah, I think it's really awesome, and there are many people there that it's open source, steal the code. I mean, they would like you to sort of reference it. I haven't put this on Shader Toy. I haven't been able to make this Shader Toy compatible. I wish I was able to make it compatible, but I haven't been able to. SMB, should we show the refraction demo as well?
Yeah. So just to note, everyone, is that all the code we've written today and all the code we've written, on all the streams, is up on GitHub. And at the end of the stream, I'll post a link up to our GitHub. But all this code is there, so you can go and play with it. It's also the first couple of projects we did are on Shader Toy as well, so you can go and find the code up there. So let's go and find the next. This is refraction 2. You want, yeah?
We can take refraction 1.
Refraction 1, yeah.
This is actually on Shader Toy. Don't say. So this is actually taking. This is instead of reflection, we're having transparent objects now. And here I actually implement the Beer's law, which is worth mentioning. And the Beer's law is what means that the further the ray travels through the object, the more the ray gets absorbed, if it makes sense, by the glass. It becomes more depth. The color here is more deep than here because it traveled further through the object. Does that make sense?
So I've just asked the bot about Beer's law, so it's up in chat at the moment. Oh, yeah. Lambert Beer's law. If you cast your mind back to high school physics, I'm sure you must have done Lambert Beer's law.
So what I did here, you saw the blue thing in the middle there. So the Beer's law absorb light. But then I thought, what if I revert it? What if I make it inject light instead of absorbing light? And that's how this blue thing in the middle kind of has this translucent look to it.
It's beautiful.
Because when ray transfer through that part, it's intensified instead of dulled. So that makes it a little bit translucent, if that makes sense. That's just pure, for me. I implemented Beer's law, and I just tried it. I liked it. I kept it.
And you changed physics, yeah.
So I don't think what you saw there was actually a fractal as well. So, and here I played with the refraction index. So this is the same shape as before, but here I changed the refraction index so that it's I think it's more like air. It's going more to air. But then we see it actually change the shape, and I think it looks nice. Then what I tried later was I tried negative refraction. I have no idea what that means physically, but the equation works. I think it's the next one that comes in. So you will see how that looks. So that's also coming back to, you build something and then you tweak on the parameters and try, what if I put in something that doesn't make sense here? And if it looks cool, you keep it. If it looks rubbish, you throw it away. It never happened.
And nobody ever knows.
This is actually Mandelbrot fractal. And once again, I use this. Yes, this is negative refraction.
It looks amazing.
What does that even mean? I don't know, but it looks cool, I think. So I kept it.
It's mind blowing. It's fantastic, that.
Yeah, but it's all. The only thing that you change here between each screen here is the object and the refraction index. And I use this thing constantly, but I have a simple object and I subtract from it, right? If that makes sense to you, right? So, and here I also use this soft min function to sort of, see that some of the bubbles goes into each other. And it's just, it's a lot of cheating, if that makes sense to you.
But a cube of Coca-Cola.
The code we did today, we could actually, instead of using reflection, we could actually make it to use refraction, because there is a function that is called refract instead of reflect. Yeah, kind of a bit. It's kind of what's nice about shader programming is you put in the wrong arguments and something comes out, and if it looks cool, you keep it and people think you're a genius. Now, when I program at work and I put in the wrong arguments, I end up deleting our petabyte data lake, and nobody thinks I'm a genius anymore. So that's why I like Shader Toy. Oh, I should put, oh no, okay, I should kept everything after the date, not before the date. Oops, sorry about that. It hasn't happened yet, that mistake. Yeah, this is actually, I did something for, this also uses reflection, but there is a program language which is called Crystal. And some guy said to me, their logo looks a little bit boring. Can you make it look cooler? I never showed anyone in Crystal language. This was just a coworker that said it. So yeah, sure, I can make a shader of it. So the purpose of this thing is actually to look like the Crystal Lang logo, but using a shader instead. And I also wanted to make it rather cheap to render. So this shader here, I actually tried to make it not to be that expensive, if that makes sense. I mean, it still consumes gigabits or gigaflops per second, of course. But every graphics card in the world can produce gigaflops. Yeah,
and in the previous streams we showed how to put this into a website, so you can put us on a web page with some JavaScript. So so it could actually be used as a logo on a web page. And all that JavaScript stuff is Mårten's contributed that, and it's up on our GitHub as well, and as well as on Mårten's GitHub.
Yeah, I think Beatler is asking about the website using WebGL, and I would say yes, it's rather easy. Since I have a question, should we show that quickly?
Yeah.
So you cloned my repo, right?
Yeah.
That I had.
Have you got something in here?
No, it's not Kodelife. There was a repo called mrange GitHub something.
There we go.
There we go. And then we have diversions. That's what I'm spending my life on.
Yeah.
And then you have SMB2. I think it's going to work, but I'm not sure. And then you double-click the HTML.
There we go. That was the one of the first shaders that we did.
Oh yeah. Okay. But still, this is a WebGL. If you take SMB.
Get rid of this.
So that's a 2D shader. I think SMB is also, but I mean, the important thing here is we have to open. I wonder if that worked. Oh yeah.
So this is our ALF hype, hyperspatial hype, which if you normally if you subscribe you get this on the stream. Now this may well be degrading the stream, so I'm not going to say it for very long.
I can degrade the frame rate at least.
Yeah,
and I think it looks weird on the stream, but we're using MS Team here, and it's not really done there. But to answer you, Beatlol, very quickly, what you see, there is a WebGL driver here, which is what I've written, and I'm not saying it's perfect at all. I'm not saying that, but the idea is to sort of make it simple for me to host WebGL on a web page. So it's not that bad. So this thing here, what that does is that you have a canvas on web page, and then you say, okay, you have a canvas. Now please give me a GL context, an open GL context from that canvas. And then from that thing, then you draw 2 triangles, and you load this shader and paint that in those triangles to make a square. That's actually what's happening here.
Yeah, so your shader code kind of sits inside here.
And it's not very interesting code, this thing, but you do it once and then it kind of works. If you look at the HTML page though, yeah, so the way I want to do it, I try to make this compatible with ShaderToy. So if not all ShaderToy examples work here, but if you scroll down a little bit here, SMB. So the point is here, if you have a simple ShaderToy, which this is, you take this code here and remove it from here to the end. Not completely. Went too far. Yeah, help me scroll up a little bit, and yeah, there, and you remove that and you copy paste your shader in there instead, and then it works.
Yeah, it's really simple to do. Thanks to
so the idea it should be you make something in Kodelife, you make it compatible with ShaderToy, and the way you make it compatible with ShaderToy is you copy paste the code into ShaderToy. And then you fix all the compiler errors, because that's what you did, SMB, right?
That's right. Yes, all I did. It's very simple.
And then when that code is compatible with ShaderToy, then you can just replace that code here, and it should work. And it often works, not always. So that's how. If anyone wonders how all these SMB hype screens are done, I've written them in ShaderToy or in Kodelife, and then I host them on my site, and then SMB pointed out.
So this is our original. This is the last stream's shader, which I converted over to ShaderToy and just cut and paste it into that code with Mårten's JavaScript library in there, and it just does it. So it's just easy to do. And just to show this is the other shader that we've got on stream. This is the follower hype shader. It's probably degrading the stream as well, so I won't keep it up for long. But
I certainly hope so. The day I make a shader that don't degrade the stream,
you'll have failed, won't you, at that point?
Yeah, I'd be ashamed. Oh yeah, this reminds me about something. No?
Yeah, Kodelife, it drops, and I think I pixelate out and just about see the. So what I do on stream, it's just a portion in the center of the screen, which I've got masked out, and it still pixelates me, but for a few seconds it's fine. But Ancient Coder, welcome to the stream. Good to see you. Have a salute from Alf. So we're a bit hyped in the stream at the moment because we've got some really nice 3D reflection shader, which we'll show you if you haven't seen it. In fact, what I'll do is I'll just reload the shader we've done. This is one of Mårten's refraction shaders, but I'll just reload the one that we did this evening, just so you can have a look. Pure Stable, thank you for the subscription. Electric SMB. Where are we? Shaders.
Yeah, so Vitler asked this before, and I saw it, but I missed it. So now many shapes many natural-looking shapes can be kind of described mathematically, but maybe a drawback with how these ray traces works is that you actually kind of model the objects in a mathematical way, and that means that some things that are, you would design an object inside a 3D renderer program using lots of triangles. That's hard to get into this concept. Can be quite hard, but I will find some shaders that I know of that looks pretty good of things that looks like real life objects. So if you just give me a little second here, I will try to find one of them. And this is not me. I will not, I haven't made these things. I'm just sharing it. So I'm not. What I mean is, I'm not taking credit for this, obviously, because I went to ShadeToy and I found some really cool sites, shaders. So I try to share it in this code share here.
Yeah, I'm just going to reconnect to code share.
Take that one.
Oh, look at this.
If you maximize the screen, I think it's you can see it. So I mean, it's not like it. We obviously see it's not real, but there are no assets here. This is just pure math. I think that's pretty cool.
The fish.
And it's not that much code either. I actually stolen this. This is a fractal, this lighting effect. I stolen that and used that in many places. I mean, I'm not sure how it works, but it looks good, so I stole it.
It does look very good,
yeah. And let's see if I can find something else.
So if you look at the code, it's... Let's see how much code.
Right, there is code, obviously, here, and it's not that little, but it's also not... It's 400 lines of code. It's not the most you ever see.
I'm getting a bit of kind of weirdness going on with the thing here, but there's also some audio that goes with that, so you can actually some of the things that we've looked at previously, they're actually audio shaders as well. Interesting.
So it's kind of possible to sort of create things that look, but you have to work a little bit, because it's this model here kind of more lends itself towards spheres and fractals. Let's find a cool fractal as well. I think we showed it once, but we haven't done it.
Yeah, Cody Bird, it'd be interesting to see how you could actually use the concept within a game. Copper Beardy, welcome to the stream. Have a salute from Alf.
I think there are ways to use this in the game, but mostly this is you. So I tell you something. A place where this is used a lot is there is something called demo scene, and the purpose of demo scene is you make something that looks amazing.
And there is a certain subcategory of the debugging called 4K. And 4K demos are 4 kilobytes big, executable. And when I first saw them, I was like, how in the world can you make, for instance, this thing in 4 kilobyte? Now, we know it's not that hard, but before I learned about, how to do these things, my mind hurt because I couldn't figure it out. Now, we haven't that much code here, so how most 4K demos work is that they programmed up this thing here, and then they have a really, really tiny loader that they written in C or whatever that is designed to be really small, and that is a real engineering miracle to write that, but it's possible and it's generic. And then what that thing does, it loads this shader and displays it. And then they do things like, so the place this is done is used a lot is in this world. But I think you could make a game from this thing here because it is possible. If you scroll to the top here,
I'm just going to show that it's 230 lines of code, and there's actually some functions we're not using in here.
And we could make it even shorter if you wanted to. I mean, it is possible to send in parameters into a shader through these uniforms. So you can control, it's not just time, you can actually have objects that have a certain coordinate in the world, right? So it is certainly possible. You can make this mouse move controlled. You can get the mouse, you see we have the mouse position here, so we could actually control the camera using the mouse, and you can imagine you can have different positions being sent in. If you want to have more complex and bigger amount of data, you can send in the data as textures. So one thing I actually been thinking about using shaders for is, we have these graphs of, pie charts, lines and things like that. And I've been thinking, boy, I can probably make some really amazing looking 2D charts using shaders that renders instantly on the screen with cool animations that will blow people away. Of course, I'm too lazy to do that, but I would send in the data points as a texture then, and then I would render using a shader, this chart, and I could animate it, add sort of transparency and all these kind of things that are quite expensive to do if you use a normal canvas that is free to do in a shader.
And the spectrum here is audio, so you could actually have this responding to, an audio track playing in the background.
On Shadertoy, there are a lot of shaders that are actually sort of, and I even made my, I made one myself. I can show you that one.
Yeah, let's have a look at that one.
If you want to.
Yeah.
I'm not promising it's going to blow you away, but it's controlled by music at least. So. There you have it. Give me a second. I need to find it.
Yeah. So this is what we built today on stream. So this we had an interesting journey, including a. So hold on to your hats here. We did flirt with a global variable. Didn't work. So we soon lost the global variable, but we have documented proof that global variables are a bad idea. But yeah. So this is what we've built today with this. Wonderful, wonderful reflections. And what we've got here is that the two objects, that the cube and the sphere, are more reflective than the surface they're sitting on. We're actually zoomed in, but this surface here is also reflective, and you can see that we've got the shadows, and we've got it's sitting in a sky with two suns. So there's a white sun and a pinkish sun, and we're revolving around. So yeah. So this is less than 2 hours work to get something like that. And
I mean, I think it's pretty amazing that we got that far. I wasn't really sure when we started that we were able to do it. I mean, I knew it wasn't that hard, but it's always a bit scary on the stream.
Yeah, when you're coding live, it's everything's multiplied by 10, so it's it can be very challenging.
You're feeling the pressure a little bit.
Yeah.
Give me if you don't mind, give me a little bit.
Shall I go onto Shadertoy and see if we can find your stuff?
Yeah.
I'm struggling loading the sound, but I'm going to fix that. So if there are questions in chat, maybe you can look into that for a moment. We'll take that one.
What's it called? The one with the sound.
The problem is if you go there now, it's not going to load the music.
Okay.
So I need to try to.
I'll let you fix it.
This is one of the problems sometimes with the sound shaders, is that occasionally they struggle to load the sound. So I'm trying to fix that somehow. Okay, well, we can make it. Maybe it works for you. And it also might be very weird music. I must warn you, because I sometimes listen to very weird stuff. I'm on Twitch, so on Twitch there are sometimes streams that are listen to very weird music. So it might be weird. I want to get this to load first. Why isn't the music working? Also, they seem to broken. Maybe it works in Firefox. You know, Firefox is the best browser, SMB, and you know why? Do you know why that is?
Well, it's interesting you say that. Is it working Firefox then?
No, Firefox has the best performance for WebGL.
Has it? Okay, interesting.
So
I've heard kind of interesting things about it and its vulnerability to its vulnerabilities, but I don't use I used to use Firefox, but they kind of bloated it. It got slower and slower and slower. And they redesigned it from scratch, didn't they?
Aren't you describing Chrome there?
Well, yes, I am. Yes. Well, any software project starts off as sleek and effective, doesn't it? And then it just degrades and degrades. So I've just pushed that 3D reflective shader up onto GitHub. So it's in the shaders repository. I think my GitHub has come up several times. I'll have to post it again. If you want to go and grab that code and play with it in Kodelife, then it's here. This is
maybe it's worth mentioning, if there are new people that didn't see it before, you're using a tool called Kodelife that is free from Hexler.
So this is the Kodelife IDE, which we're using. It's kind of real-time compilation, so you make a change and it immediately reflects the change. So there's no kind of making changes and then compiling it and running it. It's actually happening all the time, and you can go and get that for free over at exler.net. So this is their website. I'll post that into chat. If you're interested, you can get that. So this latest version, they're kind of asking for a contribution, but you don't have to give one.
No, that it's. I talked to them about it, and they are. It's really up to. It's really up to the user. If they intend it to be free, but if someone wants to support them, I'm not bought by them. I'm just a huge fan.
Yeah. They also follow on the stream, and they do kind of retweet our messages out when we're broadcasting these shader streams. So I'm grateful for that, and I feel that we should kind of give them a bit of a plug as well, because it's the tool that's enabled Mårten to teach me about shaders in a way that I can understand, and we get instant gratification, or it crashes and burns, but that's only because we weren't saving. We hit an infinite loop.
Infinite loop in a shader. Yeah. That was a bad idea. We learned that now.
We've learned that lesson, yeah. So save all the time.
I shared a link with you.
Okay.
This is not something I did, but it's something that was on ShaderToy, and it might work for you, or it might not. I don't know. It's cool when it works.
Can't see it.
Maybe you have to reload it.
Yeah, looks like it.
No?
No.
Things are not meant to be easy.
This code share has worked fine before. I'm not sure why we're having any difficulties.
But I think, to be honest, I think the issue is here that
the three of us, yeah.
Yeah, because I have in my main computer, and then I use the laptop computer for this meeting. But this computer is not powerful enough to. It's over capacity. Okay. We are abusing.
We're abusing it, are we? Never mind.
So we're probably going to get arrested now for. But my laptop can't handle the shaders. I shared with that in
Teams,
in the chat.
Okay.
Yeah. I'm not sure the sound is going to work, but it's worth a try. I have no idea what song he used as well, so that is going to be a surprise.
I hope it's not copyrighted.
I did not loaded.
No.
So that's fixed it. But okay, I want to point out something though. So this is possible to get working, but it's one of the part of maybe if you take Chrome or some other browser.
We'll try this one.
IE Chrome.
No, I don't think. Maybe there's a problem on their site.
What happens if you take the sound one? There's a link called input sound.
Where's that?
If you go into the source code and you take sound, I don't know what that is, but that might be no, not SoundCloud. This is the one you're looking at.
Well,
the one above. I don't know. Yeah, sorry for distracting you.
Yeah, I think. Oh, there we go.
Yeah, Kodelife. I like. Is there any sound here?
Yes, there is. Yeah. I don't know if chat can hear it. I can hear it.
Yeah. I will see if I can hear too. If I turn on. Okay.
So it's like a really cool kind of iTunes visualization with shaders.
Yeah, but let's just look at the code for this thing here and be amazed about the amount of code you're looking at.
So most of it's comments.
Yes.
So there's if we don't include the signature of the method and the curly braces, there's 1, 2, 3, 4, 5, 7 lines of code.
Yeah, to give you that thing. I think that's pretty cool, personally. So what does this thing do? Now, one is the second row is a sound wave. So float wave, you see they do both FFT. So what happens is that I channel 0, which is a texture, this part here contains the FFT part. And this is what gives these things back here. The wave is a representation of the sound wave, and that is what is given here. And then he just applies math on top of this thing here. So if you comment out that line here and you hit run, now you have to hit this down there. Now that is gone. You just have the FFT thing here. And if you comment out, yeah. So it's mind-blowing, I think, that because I honestly think this looks pretty good.
No, it's certainly as good as anything you get as an iTunes visualization, isn't it?
And it's code-wise is like nothing. That's pretty cool.
Yeah, there's some pretty meaty stuff going on in the background.
Well, it's an FFT and it's this sound wave. That's it. Really. The FFT is of course not trivial to compute, but I mean, the visualization just uses the FFT and the sound wave, and it just looks, I think, really good.
Yeah, and we did the fast Fourier transform stuff on our synthesizer visualization, didn't we? So
yeah, we know all about.
We know all about it.
Yeah. So what do you say, SMB?
I think
is this a stream?
It's a stream. It's a wrap. How does one listen to the audio? How does it listen to the audio? It's just there's these things called uniforms, which are like inputs, which come from external things.
So you don't see any, but so if SMB, if you click these shader inputs up there,
here. So these are the inputs.
Here are the inputs that comes in from that are implicitly defined, and you see they have defined channel 0 to 3 as a uniform sampler.
And then you get sample rates coming in here.
And here is what is channels. This is channel 0. So this guy has made. If you click here, you can show different inputs. So you can show SoundCloud. I don't get it to work today. You can show different kind of textures. There's music over here that you can use and experiment with in your shader. Videos of Britney Spears for some reason. You can see that the guy here running the site is about as old as I am, and then there are some. This is an interesting font as well, but I'm not going to talk about that. But yeah.
And here's some of the kind of the noise textures that are
used. Noise turns out to be not as simple as I thought. There are many different ways to do noise. I learned when doing this thing here. So I use something. I think it's called Perlin noise. I use for the mountain ranges.
Perlin, yeah.
I just want to show you. I think a mind-blowing shader toy before we're done. If that's okay by you.
That's fine.
And this is mind-blowing, not because of how it looks, but the amount of code. So I'm just going to find that thing here, if I can. Because I've been looking at many shaders, so I'm.
You spend all your time looking at shaders, don't you?
Yeah, that's what I do. I program shaders and I look at shaders.
You also invent new ways of distributing code, and you create formlets in F# and you do all kinds of other things, and you hold down the day job, and you're on 24/7. Well, you seem to be on 24/7 call, so.
Yeah.
All round coding super person.
Well, the thing is, when you hit a certain age, you don't get to do so much cool coding at work anymore. So then I need to do it at home instead.
I know how that feels.
Yeah. So I mean, I do okay code at work, but you have to let the young guns do the cool stuff, and you have others, you have other skills as well.
Yeah,
so
that's what I don't. That's why I don't do UI. I don't do JavaScript unless it's in D365 to control forms. I let them get on with that, and I do all the plumbing in the background. That's kind of my niche these days is integration layers.
Integration layers, because that's nobody wants to work with that.
That's
thing.
right. So I take the hit for the team and do the integration stuff, and they do all the UI. Which is fine.
Yeah. So that's where when I come home, I need to do some. I need to do some shader programming or some crazy functional programming to sort of feel like a real programmer again.
So Cody says he spends all this time upgrading stuff from the 80s and 90s. Not exciting. Well.
Yeah, I heard his woes at work.
Yes. So
that's Code Beard. Don't take this the wrong way, but when I have a bad day at work, I think at least I'm not coded Beard. So.
So Weetal says either I'm not old enough to understand the conversation, or really I'm looking where you work. You probably it could be a combination of both there, Weetal. But I'm glad you've got a stimulating environment. I'm not saying my job. I actually enjoy doing kind of moving bits and bytes around in backends with web services and things, and it does mean I there's a new kind of vista for me of containers and Kubernetes if I want to get into that. So it's not a dull dry thing, but most people who work on websites want to do the front ends and play with JavaScript and
And these cloud formation templates, they're not going to write themselves.
Oh, that's right.
So, but I'm getting help with that. So I'm not the only guy doing that. But I mean, I'm okay with that. I think it's an interesting job, but I don't write interesting code that often. If that makes sense.
Yeah, no, I mean, what I normally do is going to be kind of lots of left-hand, right-hand kind of transformations, and it's pretty much the same code every time. But I mean, it interests me. Otherwise, I wouldn't do the job.
Yeah. So I shared a link with you in Team. Another shade, sorry.
Okay, let's grab that.
So maybe next time, if you want to do next time, I'll not push myself.
Oh no, we're definitely gonna. There's a lot more we can do yet. I feel so. Let's take it as far as we can.
So I showed a little bit about this terrain marcher, right? So where I started, because I thought I want to make terrains. So then I said I want to have a simple example to look at how to make terrains, and then I found this example. Which, if you look at the code again, is mind-blowing. I think that we get this result from nothing.
I can't. It's hard to understand how that could possibly ever work.
Yes. What it happens is that he has a texture, and then he from the texture, he computes a height map. So the height map is the height of the mountains. And what he does then is he's saying, okay, we can actually simplify this program and maybe see what's happening. I did, okay, here is some magic. So if you write F, 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 F. Now, what we're looking on here, which is maybe a little bit easier to see here, this is actually the texture. The texture looks like this. But what he does here is that he repeats, he takes this same texture and he scales it down, both on the height, but also increase the period.
Yeah.
No, shortens the period.
Mm-hmm.
So he reduces the height, and that adds a layer of detail to it. And that is what the F weird stuff does. So if you do another level of F here, you see now we have some more details to it. And it also grew a little bit. And for each level of F we do, we get something that looks more and more complex. So that's basically what this is doing. But to me, this is just mind-blowing that we could get this. We could get something if you reload. I will just reload this page if that's okay with you.
Yeah.
That from almost no code at all, we get something that looks okay-ish, I think.
Yeah, I mean it's even got the kind of the fog and kind of in the valleys, and
it's just pure cheating. Yeah. It's all cheating, but so this is where I started. I basically looked at this example and said I don't get that. And then I started understanding it. And from this thing, I built my much more complex terrain shader.
So Rita was asking about line 15. I must admit, I was kind of puzzling about that. What's that doing?
Is that obvious?
No.
Okay. Well, now, so this is a macro. And if you go up here, you see define F to be plus texture.
Oh, right.
Channel 0 is the texture, and then we sample the position multiplied by scale, and then we divide it by scale. But then you see what happens here is he also double the scale while dividing by it.
Yeah.
So each application F, what will happen is that the frequency of the texture doubles, but the height of the texture is halved. And then he repeats that thing over and over again on this texture, which creates a mountain range. And this is quite stable, I think. Yeah, I think so. If we can try to find another texture, and we see that the mountain range changes, but it's still working, I think. So let's see if we find something here. We can try this one, see what happens. So, that looks weird.
Oh yes, there's another one there. Just a different mountain range, isn't it?
Yeah, it
So this is just a different look, and it looked strange, but it still looks. Yeah, that looks strange. Maybe we can click on the font. But I mean, this looks pretty good.
Yeah.
Honestly. And then the shade is just it's just hacking. So shall we try the? Oh, is that the font? You can try the noise texture, but I think the problem is that this is
it's too random,
white
isn't it?
noise. Yeah, and white noise is not good for this thing. So that is why he used this texture here, because it's not random, but white noise doesn't make a good mountain range.
No.
Yeah, that's my, Mårten's proverbs. Like wisdom. White noise don't make good mountain ranges.
Yeah.
I write a book about that.
I think, but look at the Cody Beard's message there. He should write a book about looking after code that's 30 years old. Adventures in 30-year-old code or something like that.
I have a friend. I joke with him sometimes. I started assembly programming, and my friend did that as well. And if I was thinking what I do now from what I started with, I would never guess that. But he is an expert on copy pasting, implementing smart copy paste. And I used to joke with him about that. Did you imagine that your job in the future would be to implement smart copy paste? Was that the reason you started programming? I'm just checking. It could be.
That it.
But sometimes we, SMB, right? We need to do things like this.
Absolutely, yeah. I always think of the I do is that that's the glue, and nothing. All the fancy websites wouldn't work with that my bit of glue in the background. So
no. We're fighting the good fight. We're doing that job, but it's also cool to do this kind of stuff.
This is definitely cool. I mean, and to say we're kind of taking baby steps here, and we're not kind of blowing anyone's mind, except mine, I suppose. But it's just, I just find it fascinating. This. So, like I said it before, there's something primal about drawing pictures on your computer. It's a bit like with my audio ones, making sounds with your computer.
Yes.
But this is like a whole new level.
Yes. But to be honest, we had your example, and we made a few mistakes. But the only thing we did really was to compute the reflection array. And then we did a few extra loops that we followed the reflection array.
Yeah.
And that's what we did to get this quite nice looking reflection, in my opinion.
You let me in for a Bob Ross quote there. We didn't make mistakes, we had happy accidents.
Yes, that I haven't watched much of Bob Ross, but that's exactly what we do when we're doing shaded programming.
Yeah.
So we can certainly improve the shape. Maybe next time we tweak a little bit on this thing, but then we can do terrain branching, because then we're going to use a different kind of. We're not going to use what's called sphere tracing. We're going to use a technique called height tracing,
right?
Which is not that complicated, but it's a little bit different, and that will allow us to ray trace mountain ranges.
We should definitely do some terrain next time. Definitely.
Yeah. And then we can, so we can generate a mountain range, and we can then add snow to it. I think that's basically a one-liner to get snow on top. So I think we can do some pretty cool stuff in a few hours.
I think Dragon Eye's teasing us here. He's talking about high mem. So he's obviously trying to allude that we're so old we used to use config.sys and autoexec.bat.
Config.sys, those were days.
We did Dragon Eye, yeah.
Yeah, so I used to sit with config.sys and HighMem, or was it HighMem? I don't remember actually, it's so far ago. Out to exit back to the config.sys to get more HighMem on my machine. I had to put more drivers into the HighMem so I could play TIE Fighter with mouse and sound at the same time. And that was a challenge.
Yeah, I think I may be a bit older than Mårten. I've actually programmed with punch cards.
Yeah, I think a slightly bit older.
So yeah, that was in Fortran, and I did drop them once and had to do the whole thing again because I couldn't put them in the right order.
Oh no.
Yeah. Okay, so thank you so much for that stream, Mårten. It's been fantastic. So yeah, so all this code that does this shaders up on GitHub. So do take a look at that and play with it yourself. See what you can do. Start to kind of make some changes to the code and see where you can go with it. Next stream for shaders is obviously depends on Mårten's availability, but we'll think about maybe on Monday doing another stream with some terrain shading. But I'll keep you all informed via GitHub, not via GitHub, via Discord and via Twitter. My Twitter account is this one here, so do pop over there and follow. Thank you for everyone who's followed the stream today. It's been very kind of you. We're kind of inching our way towards our target. Yeah, thanks to Mårten. Infinite thanks to Mårten.
No problem at all. I hope I didn't ramble too much. I felt I was maybe going a bit on a rambling streak in the end.
No, I think we enjoy your rambling, Mårten. So it's always very interesting stuff, and it's just amazing what you can do. So thanks for kind of passing some of your expertise on to myself and to the rest of the viewers. It's wonderful stuff. So this video will be available on Twitch for the next 60 days, and also it will be posted within the next 24 hours up onto YouTube on my channel there. So I'll just post that up. Do tell your friends about the shader streams if you're impressed by what we've done, and how remarkably kind of, I won't say it's easy, but it's not complicated. There's some basic maths, and I think in our first shader episode we did discuss the concepts of dot products and cross products. So if you were confused by that, it's kind of the first chapter of a high school linear algebra book. So you don't have to go further than the first chapter to understand all the concepts that we do in terms of the math. Other than that, there's absolute, min, and max. And
I think we touched that on the first stream. So if anyone is interested, we had a discussion about distance functions. That is not.
I think that's a key one, isn't it? So yeah, going back to the first. Thank you very much for that follow, by the way, Essert. Yeah, distance functions is the key to the whole thing, and it sounds exotic when someone says, "Oh, we use distance functions," but if you go back to the first stream, episode 61 or 2, there's a kind of very graphic illustration when we start to work on building the 2D shader and what a distance function actually boils down to. And that's what you're seeing on the screen. This is the output of a distance function with various lighting effects and reflections added to it. But the cube with a hole in it and the rotating sphere are just the output of a function which says how far is it from one thing to another, basically.
Yes.
With a bit of the ray marching is also a bit added complexity to that, but yeah, it's straightforward concepts.
That's why I start with 2D, because I think it's easy to understand in 2D what the distance function is. It's easy to see it, and then we expanded from that into 3D, because here we cannot really show the distance field. It's not really possible to do that. But I hope with the 2D, it's easier. What do you think, SMB?
Yeah,
it's easier to visualize it.
I don't think you could do it in 3D.
No.
And it's the same with the Boolean algebra on the shapes. It's easy to understand what's going on in the 2D. It's more dramatic in 3D, as you can see there with the cube with the sphere scooped out the middle of it. But the concept, it was right to start with 2D shaders, because I don't think we could have progressed this far. This is only the third stream, so there's been one 2D one. Then we jumped straight into 3D in the next stream. So the 2D one, we did a kaleidoscope, was just basically to kind of introduce us to the concepts that underlie this. Obviously, the 3D bits where you start getting the wow stuff, the interesting stuff. But yeah, I don't think we could have got this. I couldn't have followed the stream and the logic of what we were doing without seeing the 2D shaders first. I think that's valuable. And the other thing to mention is if you go onto any website that talks about GLSL, they immediately start talking about triangles, drawing triangles. We haven't drawn a triangle in any of the streams, have we?
It's too hard with triangles.
Yeah, it's too difficult.
Yeah, this is much easier.
So, so it's a different approach to what you might find on some tutorials on the internet that talk about shaders and GLSL. So I'm hoping it's a different kind of slant that you might have come across before if you have investigated shaders. Just kind of, we've got 18 viewers in chat. What have you thought about what we've gone through? Chat, has any kind of think you'd like to see us do in future streams? We take guidance. So we did have a member of Discord did request some water, and you want enlightenment, Dragon. Well, just keep staring at the shader.
Yeah.
The more you watch the shader, in fact, what you could do is go back to our 2D one and look at the just stare at the kaleidoscope. Yeah, terrain and water. So I think that's where we want to go next. Certainly with start off with some mountain ranges, and then maybe get some water. As I was trying to say, that there's one of the Discord members wanted a reflective sphere above water. I think he was kind of challenged to do it or something.
It's some job application. But we actually could add this down here to this thing, because what we could do is we could the box on the bottom, instead of, we could compute the normal being the normal of the water. So we could totally do what he was asking for now, but we got distracted. At least I got distracted.
So maybe we could do something like that, but we'll certainly do the train, and I think we do want to do some water as well, because it's always quite fascinating, isn't it, when you see that, and the idea that that's actually being calculated on the fly in real time by your super powerful GPUs. Okay, so thank you everyone. That's nearly 3 hours of streaming. So I don't know about you, but I think that's pretty much enough for me tonight. So thank you once again, Mårten.
No problem.
I'll be in touch and we can plan the next stream when it's convenient to yourself. Thank you for everyone who's viewed. Thank you for all the followers. It's been fantastic, and thanks to Gareth Hubble for the raid. And thank you for those people who stayed, because it's really appreciated. So take care, everyone. Let's go and find someone to raid ourselves, shall we? So let's go over to Twitch. Oh, I'll see what's going on. I'm in Edge, aren't I? So if there might be somebody around, we can go and raid. Have a look. Oh, we've got Lannan, so let's go and raid Lannan, shall we? Do stay with us for that. I'm not sure what he's up to today, but he's usually got some interesting stuff. Okay, take care everyone, and enjoy the raid if you stay with us, and we should be back next Monday with a shader stream if Mårten's available, or it'll be a text adventure stream. So take care everyone, and I'll see you then.